our explanation. Okay, so exponential equations, they're all the ones we're going to look at for now are going to be something like f of x equals a times b to the x plus q, where a and q are doing what they did before. A is going to stretch the graph up and down. If it's negative, it's going to reflect it. And Q is going to move the graph, translate it up and down. So let's maybe just sketch a function or two, and let's even go a bit bigger there and say, what happens if we given some functions to sketch? So I'm going to run through some. So let's go for g of x equals, excuse me, 3 times 2 to the x, and we're going to move that up by, let's move it up by, let's say, 24, and see where that gets us. Okay, so there's our function. We recognize it as an exponential equation. Oh, excuse me. An exponential equation because we've got the x in the exponent. So if we're on a George, we know that our most basic exponential function just goes like that and rises exponentially. We also know that it crosses the y-axis normally at 1, and that there's an asymptote here on the x-axis. Welcome. Anyway, just going through exponential equations, and I don't know if anyone else has come in. You're welcome to stay to hear an explanation of exponential equations, or you can go off and work and come back later. Okay, so we know that's what our basic exponential looks like. We also know we...
Sorry.
Yeah.
Sorry, sir. So do you know what the link is? Because the Nanda Kota doesn't have like the Google Classroom and stuff.
Cool. I'll paste it on the chat here.
Okay, so
Copy joining info. If you click on the bottom left of the chat, it comes up, but I'll just paste it here. Paste. Just get rid of the phone number because phoning to the States will be quite expensive. Okay. Cool. So there's our exponential equation. 3 times 2 to the x plus 24. We know that the 3 is going to stretch it up a little bit, and we know that 24 is going to move the whole function up by 24. So let's look at our Cartesian plane, our x and y axes, and see what we know. The 24 is moving our asymptote up. And the sooner we can kind of think about our asymptote, I think the better. So what the asymptote is saying is that the function is going to get closer and closer to that value. So 2 to the power of x. We know that no matter what number you put in, so you take your calculator and you plug in 2 to the power of anything. 2 to the power of 100 is going to give you a massive number. And we know that 2 to the power of negative something is just going to be a fraction. So this 2 to the x is going to get closer and closer to 0, but it will never get to 0. Therefore, this whole bit in front will be close to 0, but will never get to 0. Therefore, this whole function, 0 is the smallest part that this is going to get to. Very close to it. Not even 0, but really, really close to it. So it means that the smallest value this is ever going to be is the value 24. So it means that there's an asymptote sitting here at y equals 24. The function's never going to reach it, but it's going to get very and very close to it, depending on what x is. We know that it's an exponential, so we know it's got this exponential shape to it, sliding up like that. Whether it's going to look like this or whether it's going to go down depends on this too. If it's a number bigger than 1, then it's going to go up. If it's a fraction, it's going to get smaller. So we know that it's going to have this shape going up because this 2 is a number bigger than 1. It's not a fraction. So we know that this shape is going to look something like this. Don't know exactly what the y-intercept is yet, but we do know that the asymptote is 24 because everything's gone up by 24, so therefore our asymptote's 24. And we do know that it's this kind of shape because it's a 2, it's not a half or a third, and we know that this is not a negative, so it has not reflected. So we have an idea of what this shape looks like that. Now we can work out what this value is. And this value is kind of easy to work out always. And let's do it here in blue to say, what is our y-intercept? And I think you've got quite a good handle on the y-intercept of any function. We know that the x value here is 0. So if the x value is 0, how are we going to work out what the y value is? Well, we're just going to substitute it into our equation. So we're going to ask ourselves, what is g of 0? When the input's 0, what's our output? So we've got 3 times 2 to the power of 0 plus 24. Don't even need a calculator because 2 to the 0 is 1. 1 times 3 is 3. 3 plus 24 is 27. So this point here is 27. So therefore we know that 0, 27 is on our graph, and there it is. If we were to try and work out what the x-intercept is, because I've already drawn the picture, we can see that it never crosses the x-axis because it doesn't even get past 24. So what would happen if we try to work out what the x-intercept is? What's going to come out? I mean, if we get an answer, it doesn't make sense. So to find out what the x-intercepts are, and we don't need to do this, but just to show that there aren't going to be any, we could say, well, the y value here is 0. So 0 equals 3 times 2 to the x plus 24. But if you try to solve that equation, you're not going to get any solutions because let's subtract 24 from each side. So negative 24 equals 3 times 2 to the x. Okay, divide by 3. Negative 8 equals 2 to the x. But 2 to the x can never be negative 8. You can try as you like. 3, that's positive 8. Negative 3, that's 1 over 8. This is always a positive value. So this would give you no solutions, which matches our graph because it never crosses the x-axis. So that's if we were given something like 3 times 2 to the x plus 24. Let me run through a second question, and then hopefully I'm sure you're going to have a few questions about this. But let me do one more because it might answer some of the questions. Let me just make sure this is saving all the time. So this is the same PDF that's going to be on the website if you didn't get all of that down. Let's say that we've got a new function which is g of x. Was this one g of x? No. Yeah. So let's call it h of x actually. So h of x is minus 3 times 2 to the power of x plus 24. Okay, and let's see what this function now looks like. So there's our starting point. We know it's an exponential function because the x is in the exponent. So let's run through our thinking. So I think it's quite useful if you can to view what this picture would look like. So 2 to the x would look like this, just going up. The negative 3 would take that, so this is what 2 to the x would look like. Minus 3 times 2 to the x would take that, and it would reflect it about the x-axis. So instead of going up, it would come and then start going down. And the plus 24 is just going to take that and move it up by 24. So it's going to be the same shape, it's just going to be a bit higher. So let's draw a set of axes so we've got something to start pinning our thinking to. So we've got our x-axis, our y-axis. In our general function, exponential function, we know there's an asymptote here on the x-axis. Multiplying that asymptote by anything isn't going to make a difference because it's not going to move up or down. It's 0, so it's not going to suddenly become 3. So here's our asymptote, and it's moved up by 24. Same as we did last time. So let's put that in. y equals 24. There's our asymptote. I've said that I could work out from this that it's 2 to the x, which means it looks like it's going up, but it's been made negative, so it's going to have that shape. So I already have a sense that this thing is going to look like this. It's going to go down in that shape. But how are we going to know that it's definitely that? So I'm proposing to say, well, I know that this shape would have looked like this, but it's been reflected, so it's going to look like that. That's what I think it's going to look like. And let me label it H. Let's see if that's the case by trying to work out what our X and Y intercepts are. And see, does that shape make sense? Because it might not. How do I not know that it's going to go down here, or down here, or maybe through the origin? All I know is that it's that shape, and it's been moved up by 24. But if we could find the X and Y intercepts, then we're going to be good to go. How do we find the Y-intercept? I think is normally the easiest. Well, for the Y-intercept, we know that x equals 0. So let's see what happens. H of 0 equals negative 3 times 2 to the 0 plus 24. Okay, so if the input's 0, what's our output? 2 to the 0 is 1. 1 times negative 3 is negative 3. Negative 3 plus 24. Cool. Good to go. 21. So x is, our y value at least is 21. And this is why I said, even now, I made a bit of a mistake and said x equals 21. I think it's always useful. Just, what were we doing again? Oh, when our input's 0, our output's 21. Now we've got nice coordinates, because only coordinates exist in the Cartesian plane. There's no one value. So 0, 21. Hey, that matches with what my first idea of what the picture looks like. 0, 21. Which means there should be an X-intercept as well. It's not suddenly going to go back on itself, so it must be over here. How do we find the X-intercepts of any function? Well, that's when y equals 0. So 0 equals negative 3 times 2 to the x plus 24. Okay, let's subtract 24 from each side. You might solve this in a different way, but my thinking is let's subtract. So we got negative 24 equals negative 3 times 2 to the x. Cool. I'm going to divide both sides by negative 3, so we don't have that negative 3. So divide, let's actually show that thinking. Divide by negative, that's a terrible 3. Those will cancel. Divide by negative 3. So we'll have 8 equals 2 to the x. 2 to the what gives us 8? Well, 3. So therefore x equals 3. Let's just sum up. What were we doing exactly here? We said when x was 3, y was 0. So now I know that 3, 0 exists on the graph. There it is over there, 3, 0. If I didn't have a good idea of the shape, and I didn't know where it was exactly, because I've got those 2 points, then I know that there's only one way I could draw this exponential. I'd have to draw it in that shape. So there's our h going in that shape. It was 2 to the x, and then it was multiplied by negative, so I know it was reflected, and it moved up by 24, and we got that shape there. But our algebras backed up our thinking, or our algebra would help enforce what our thinking should be, what the graph should look like. 0, 21, and 3, 0. Well, now there's only one way I can draw this. I can't, I'm sorry, I just can't think of another way to draw an exponential that's going to go through those 2 points. So that's a quick run through maybe of exponentials, exponential functions at least. And then the one remaining one to do is if this is a fraction, but I want to pause on that and just see what questions there are at this stage about exponential functions. So, who's got a question? And his hair's looking good. Any questions there?